Okay, since I know everyone's ready. Class?
Yes.
Okay, good. Thank you very much. Okay, for all the people that decided to not show up today, how dare you? Just one person.
Yeah.
Yeah, anyway. All right, so derivative polynomial function. We've done some of these derivatives. It is the voodoo magic. And the derivative of y equals e to the x. You'll like that one. Okay. Find the function at a number c. Okay, if the constant function of this, then, now, constant, what does the word constant mean? No variable. If it's no variable, so there's no x, it's constant. It's just a number. The derivative of a constant is 0. Derivative of a constant is 0. So if there's no variable, my derivative comes out to be
0.
There we go. And for this one right here, it's going to look like this. So this is the derivative with the change in x. So that means that my dx, ddx. So dx means I'm taking the derivative in terms of x. That's what that notation means. So my function is a. I'm taking the derivative in terms of x. There is no x. I get 0. Okay. If it's just x by itself, the function by itself is x. Okay. If you guys remember the rule that we had. So f of x equals x. And I'm going to put the 1 right here just in case. What number is in front of my variable?
1.
There's a 1 there, right? It's implied that there is a 1 there. It's implied that there's a 1 there. So I'm going to multiply. So I'm going to look like this. So remember, we multiply the exponent times the number out front. So this is going to be 1 times 1. So f prime is 1 times 1. And then there's my x. And what do I do to my x? What do I do with my exponent on my variable? Minus 1. So this is x to the first minus 1, right? Hopefully.
Yeah.
Good. So 1 times 1 gives me?
1.
1. Very good. So this is going to give me f prime of x is equal to 1. And this is going to be x raised to the, what is 1 times 1? Or I'm sorry, 1 minus 1? 0. Thank you. So anything to the 0 power gives me 1. Anything to the 0 power is 1. So this turns into 1 times x to the 0 power is 1, which is, there it is right there in fancy notation. Then I'll tell you you are wrong. Okay, all right, anyway. So f prime of x means the same thing of d dx. So that means taking the derivative in terms of x is 1. That's what that means. So this right here and these two right here, it means the same thing that I'm taking the derivative in terms of x on that. That's important. Oh, hey, look. It's almost like the exact same thing that I was just talking about, where we take the exponent, we multiply by the number out front, and then I subtract 1 from the exponent. Now, here's another way of actually rewriting it. Instead of saying f prime of x, we could also just call it y prime. So that means instead of having a function f of x and taking the derivative of that, we have the function y equals. And so when I'm using the function y equals, I would just say y prime is the derivative. That little tick mark, y prime. Okay? So that's the derivative of that, which is also the same thing as saying, okay, d dx, so the derivative in terms of x, or you might see it like this. So dy, so I'm taking the derivative of y in terms of x. So all these things mean the same thing. Then I'm taking the derivative. So the top of it is referring to what I'm talking about. So I'm taking, so in this last one right here, I'm taking the function y, okay, whatever my equation is for y, and taking the derivative in terms of x. Does that make sense? Is that nonsense? Does that make sense? No? Not at all. Okay. You like this? This right here? Yes? We okay there, right? Okay. This right here means the same as this. So I'm taking the derivative. Okay. This one right here, there's nothing up here saying the derivative of whatever function I have. And this is dx. This is mean that my variable that I'm using, that I'm taking the derivative of, is x. This is important notation because sometimes you're going to have a, let's say, y equals five x plus 2z. This is important notation right here. So if I had this, that means that I would have take the derivative in terms of x, right? So even though I have two different variables here, I have an x and I have a z here, right? So I would only take the derivative in terms of the x. And so that means z is not a variable in this case. So I would just treat this as if it is a constant. That's what that means, because you're going to see some of those. Is that better now? Okay, what about dy dx? dy is going to be like this function right here. Because it is saying that my function y, or my equation y equals, right? And I'm, again, taking the derivative in terms of x. So I'm deriving in terms of x instead of the z. What? What way? Whiskey. Cool quick.
A friend.
So he's saying like this?
I don't know.
Actually, all four of these are the same.
They're
Saying
all
that
the same, like
all four are saying the same thing. They're saying the same thing. They're just saying derivatives, but one refers to a specific one. So the dy dx would refer to this one right here, the y prime. That means that it is the equation y, and we took the derivative dy dx in terms of x.
okay, so dy and
Yeah, they're all the same thing.
okay, they're all the same.
They're all the same thing. You're all going to see them all at the same time, at different times.
You were just pointing out one of those, like.
Okay, ddx normally goes with the f function right here. Yeah, so normally if you see an f function like this, you're going to say ddx, because there is no, you're not going to have like the df of x like this. You're not going to see it like that. So if normally if you see a function, you would just turn it into d dx, not df of x over dx. Kinda, maybe.
It's like
And then dy, because this one right here, this, you don't see this type of notation. You normally just see it like this at all. Let's actually get to some math then. So take the derivative of x to the fourth. So that's what this says. We're going to take the derivative of x to the fourth. So x to the fourth. What am I going to do? What number's out front? So it's going to be 1 times what? No.
Oh, 1 times 4.
1 times 4, right? So this is going to be 1 times 4, which is 4. Yes?
Yeah.
X raised to the
One.
or minus 1, which is 3. So we're saying that dx of x to the 4th is 4x to the 3rd. Okay, and let's try that other one. So g of x is x to the 10th power. My notation for this would say, what's my notation for this one?
D over dx.
Neither.
Y to the 1.
Yeah, g prime.
Okay.
Because I started with g, right? So this one gives me the name. This one gives me the name g, just like if it gave me the name f of x. So this is going to be g prime of x is that's it. Super crazy, right? Good. Constant multiples. If a function f is differentiable and k is constant, then f of x is equal to k of f of x is a function that is differentiable. Okay. Here, let's actually do the math so it makes it even better. In this one right here, f prime, let's see if you guys paid attention to my steps. The number out front is, say 5.
5.
Good. Okay, so it's going to be 5 times,
3.
good. 5 times 3 is, so f prime of x is 5 times 3,
15.
x raised to the, bam. Does that make better sense? Because if you had to try and read it in words, it doesn't really make sense. But seeing it in action, it's the same thing I showed you in the first place. Your power multiplied by the number out front, and then subtract 1 from my power. All right? What about this one? So this says that I have function g, and I'm taking the derivative of, say, u. U is my variable that I'm going to take the derivative of. So, what would the name of this would be?
G prime of u.
G prime of u is equal to -1, because it is -1/2 times 2, right? So it's -1 or just negative u raised to the first power, right?
Yeah.
Because 2 minus 1 is just going to give me 1. Do I need to put the 1 there?
No.
No. It's not necessary to put the 1 there. But if you need to try to remind yourself where it came from, you can put it there. I'm not going to mark it wrong for anything. That make sense? All right, so now, I want you people to try C, because this one is crazy. I love this one. All right, you ready, Denny? Okay. So, what am I going to call this one?
U prime.
U prime of x, right, is equal to, Denny, what you got? 3x squared. You're almost there. Anyone else have something different? Say it again. You have what?
3 pi to the fourth power.
Right.
Yeah.
Is pi a number?
It's a theory.
It's,
No.
it's an idea, but it's considered a number here. So in this, okay, pi represents a number, right? It is a number. So pi to the fourth power, isn't that still a number? It's still a number, even though it just looks weird, right? It's not a variable, so it's still a number. So it's basically, I took the 3 and multiplied by that which is out front, which gave me the 3 pi to the fourth. Good job. And then my variable is x, and then I had to use the rules for x by subtracting 1. Nope,
No.
can't do it by pi. You know why?
It's a number.
It's a number, it's not a variable.
So then
Pi doesn't vary.
So then technically it would be the 3x squared.
Yeah, pi to the fourth. And so you would still times pi to the fourth right there. Okay? But right here, perfect. Good job. So, yeah, that one's tricky, and that's the reason why I like that one, because you had to see, okay, pi is a number. The number is in front of my variable, and I just multiply the 3 times the pi. Good. All right, derivative, each function of two functions are f and g differentiable. Okay, then we just add them together. Find the derivative of this. Okay, same rules apply. So what am I going to call it? F prime of x, very good. So f prime of x. Now just do each term individually. So this first one is going to give me x to the third power. Yep, negative 12 x to the first power, right? First power, right? Very good. What am I going to have next?
Probably 2.
Plus 2.
X to the 0 power.
Okay, what is x to 0?
1.
1. So it's going to be 2 times 1 is just 2. And then see this negative 3 out here? Does that have a variable?
No.
No, if it doesn't have a variable, that makes it a constant. And the derivative of a constant is 0. So that piece goes away. Does that make sense? Okay. Now we have the equation of the derivative. Equation of the derivative. So part B is saying that I'm going to take f prime of 2. So what does that mean I'm going to do? What am I going to do with that 2? Everywhere that there's an x, I'm going to replace it with the number. Let's do that. So it's going to be 8 times 2 cubed minus 12 times 2 plus 2. Do the math for me, please. do the math. Like, actually, like, plug it all in, and then you should get a singular number. Hmm?
And it goes through how many?
I do.
Oh, yeah.
One female, one male, that's normal, and one that is a buck. One that's a buck, and the other one is a. He got neutered. I have another male, but he's neutered.
Oh,
He's his name is Barbecue.
cute.
Go kebab. All right, so f prime of 2 is going to give me 42, right? You guys agree? Yeah. Okay, we just plugged it in. Okay, so that's actually pretty good there. So now, what does that mean in terms of all this? So the equation is f of x. The derivative is this right here, and the derivative at 2. What did I always say that the derivative is going to give you? The derivative is always your something of the tangent. Very good. It's a slope. The slope of the tangent line at a point. So at the point 2 of my function up here, the slope of the tangent line would be 42. It's a very steep slope, right?
42x.
Nope. It would be 42x, but the slope is 42. So rise over 1 would be, it's,
42 over 1.
yeah, 42 over 1. So the rise is 42, it's over 1. Okay? That's what that means. Now find the slope of the tangent line to the graph at the point 1, negative 5. So we had my f of x. I'm going to rewrite all it here. F of x was f of x was. Why are my notes all out of order? There it is. Minus 3. My f prime of x is 8x cubed minus 12x plus 2. Okay, and so now I'm looking for at negative, no, that's positive 1, comma, negative 5. Positive 1, negative 5. So what x value am I looking for? At 1, right? So I'm looking for the x value at 1. So if I were to plug this into my function, my y value is negative 5, because that gives me the coordinate. So if I plug in 1 to my function, I should get negative 5. But now if I plug in 1 to the derivative, right here, plug in 1 to the derivative, that's going to give me the slope of the tangent, right? It's supposed to give me the slope of the tangent. So let's go ahead and do that. So f prime of 1 is 8, 1 to the third minus 12 times 1 plus 2. Do the math for me, please. And what'd you get? Elizabeth, what'd you get? Negative 2? That sounds right. You guys agree? Negative 2? Yeah. Because this is going to give me 8 minus 12 is negative 4 plus 2 is negative 2. So f prime of 1 is negative 2. So what do we say that f prime at a point always gives me? That gives me the slope, right? Of the tangent line, slope of the tangent line. So now it's asking for the equation of the tangent line. So the equation of the tangent line, I'm going to use point slope y minus my y value here is negative 5 is equal to my slope, which is negative 2 times quantity x minus 1. And if this one right here was the AP exam and the free response, I would say leave it right there. So a free response, leave it there. That is correct answer. But if it is a multiple choice, it's most likely going to give it to you as a y equals. You might have to rewrite it or do some more work to make it into y equals. So negative negative makes this plus. So I'm going to subtract 5 to both sides. So it's going to be y equals, let's distribute, negative 2x plus 2. And this 5 over here, I'm going to subtract 5 from both sides. So it's a minus 5. So my equation of the tangent line, negative 2x minus 3, is the equation of my tangent line. Now, questions over this so far? No? Nothing? Easy? Yes, hopefully? Usually when we get to this point, people start noticing, they're like, oh, this is an easy pattern. This is where the calculus becomes easy.
Until you get to
Every,
algebra.
huh?
Until you get to the algebra part.
The algebra is what we had to get through to get to here first. So in previous years, I used to skip all that because that wasn't part of our curriculum. That was actually supposed to be done in pre-calculus. So all the limit functions were in pre-calculus. So I didn't have to do that. We would go straight into here, and then everyone's like, wow, calculus is easier than, even pre-calculus. Because it's a different math, it's new math. Okay, so that took care of find the slope, find the equation. Now the next one is I am going to find the equation of the normal line. Okay, so let's do normal. So this is my tangent. The normal line what do we know about the normal line? Normal line is always something to the tangent, not parallel, perpendicular. It's perpendicular to the tangent, right? It's perpendicular to the tangent. So if it's perpendicular to the tangent, what do I know about the slope? And yes, opposite and reciprocal. So if you did not remember that, write that down for this. The slope of the normal is opposite reciprocal to the tangent. So if my slope is negative 2, so let's go ahead and plug this in. So the slope is negative 2. I'm going to go y minus negative 5. I'm using the same coordinate equals. So what's the slope going to be for my normal? Denny, what's opposite reciprocal of negative 2? Positive 1/2 times x minus 1. So there's my point slope there. And do a little bit of math here. So I'm going to get plus plus y equals 1/2 x minus 1/2 and minus 5. And then I need common denominator to try to negative 1/2 and negative 5.
10/2.
This is 10/2, right? Negative.
11.
Very good. Negative 11/2. So y equals 1/2 x minus 11/2. Because we changed this one into 10/2, because that's still 5, right? So it is negative 1/2 minus 10/2. They have common denominator, so they're both negative, gives me a bigger negative 11/2. And right there, I am going to do the last part. And then I'm going to, let's see if I can get it. Let's do the last part. And the last part says we need to use technology to graph it. Yep, you should be pulling out that calculator. Your handy dandy calculator. Why would I do that? All right. So let's go ahead, graph. So let's take and graph the function first. The function. Yes, that is the function. F of x would be 2x raised to the 4th minus 6x squared. You all right? Uh-oh. It's right there? Oh, get it. Oh, okay. Sorry. Minus 6x squared plus 2x. And then minus 3. There's my function. It's in blue. Now, if you look, x value is 1 right here, right? The x value is 1, so it's going to be down here somewhere, right?
Yeah.
Okay. So let's go ahead, and all you have to do is hit tab, and we're going to enter the next equation. And that is going to be the equation of the tangent. So equation of the tangent was
Y equals
negative 2x minus 3. There we go. So what that is saying is, right here, at the point, actually, let me go menu trace so I can show you. And go 1, right here. So at that point, 1, negative 5, those two are touching right there, but it's only touching at one point. It's only touching at the very edge right there. So there is the equation of the tangent in red. And now I'm going to put in my normal. So I have my function in blue, my tangent in red, and the normal was going to be, was a positive 1/2, right?
Positive 1/2 x
Hit control divide to make this one easier. And it was minus 11/2. Yes?
Yeah.
Okay. Hit OK. There we go. So again, it is touching right here at the same equation, the same point. It's touching at that same point. All three are actually touching at the same point. Menu, trace, graph trace. There we go. All of these are touching at the same point. So you can see that the normal is perpendicular, so it's creating a right angle to my red line here. All right, questions, concerns, complaints of what these are and why we do it. Any questions?
Options to, like, where,
Fractions are your friends, not food, okay? They are a lot easier than doing any decimals. Decimals suck, and you need a calculator when you get into big decimals. Fractions, it's, yeah.
are we ever gonna see decimals?
Yeah, you're gonna get like real decimals, but those are gonna be your new more often than not, it's gonna be the calculator type questions only.
Alright.
So where you actually need calculator to do it. All right, so there we go. So I'm gonna leave off there, and we're gonna pick up the problems that involve ease and a couple others on when I see you Friday.
Friday, yeah.
Yep, on Friday. So make sure y'all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff for the merch store. I dropped some new merch in there, just so you know. Okay.